Here we have this function h of x equal to x, and we want to find its derivative h prime of x. Notice this function is very simple to take the derivative of. However, I'm going to use all the derivative rules to apply to this function to take the derivative. So I'm going to use the power rule, and then the product rule, and then the quotient rule, and then the chain rule to differentiate this function in here. So first, let's use the power rule. So remember, the power rule is when we have x to the n, that n gonna go to be a multiple of x, and then it can be subtracted by 1. Now let's apply it to our function. So here I'm gonna write it h of x equal to x, and then the power of that gonna be equal to 1. So the derivative of that function going to be equal to 1, and then x, and again the power going to be subtracted by 1, and that going to be equal to x to the 0, and then anything to the power of 0 just equal to 1. So the derivative of x is just 1 by the power rule. Now we're gonna use the product rule. Remember, the product rule applies when we have two multiply function and we want to take the derivative of them. That's gonna be the derivative of the first function multiplied by the second function plus the first function multiplied by the derivative of the second function. Again, this is our function, just x. To able to use the product rule, I want to write h of x as 2 multiply function. So I'm gonna equal h of x equal to 1 and then multiply it by x. This is 2 multiply function. I'm gonna call one f and then g x. So again, f is equal to 1 and then g equal to x. Now I'm gonna take the derivative of each of f and g. The derivative of f is 0, and then the derivative of g is just 1 using the power rule. Now, the derivative of 1 multiplied by x going to be equal to f prime multiplied by g, and then plus f multiplied by g prime. So f prime going to be equal to 0, then g equal to x, and then plus f, which is 1, and then multiplied by g prime, which is also 1. So that's gonna be equal to 1, and this is exactly the same thing we found using the power rule. Now I want to use the quotient rule. Remember, the quotient rule applies when we have two divided function. It's gonna be the derivative of the first function multiplied by the second function minus the first function multiplied by the derivative of the second function on the second function squared. And then again, our function is x. So here, to able to use the quotient rule, I need to write our function as 2 multiplied function. So I'm gonna write it as h of x equal to x, and then the denominator we're gonna be equal to 1. So here I'm gonna assign the top to be equal to f, and then the bottom to be g. So f going to be x, and then g equal to 1. Now I'm gonna take the derivative of each. F prime here going to be equal to 1 using the power rule, and then the derivative of a constant is just 0. Now I'm gonna apply the quotient rule. This is going to be equal to f prime multiplied by g minus f multiplied by g prime over g squared. So here f prime is equal to 1, and then g is equal to 1, and then minus f, which is x, multiplied by g prime, which is 0, and then g squared, it's 1 squared. This is going to be equal to 1 minus 0, and then over 1, which equal to 1 over 1, which equal to 1. This is exactly the same thing we found previously. Now we will use the chain rule. Remember, the chain rule applies when we have a composite function, that's a function inside of another function. The derivative is going to be the derivative of the outside function multiplied by the derivative of the inside function. So here, to able to use the chain rule, I'm going to write our function as a composite function. So h of x going to be equal to x and then to the power of 1. Now, the outside function gonna be x to the power of 1, that's the outside, and the inside going to be equal to x. So, I'm gonna take the derivative of h of x. It's gonna be the derivative of the outside function, that's gonna be 1, and then x, and then the power gonna be subtracted by 1, and then multiply by the derivative of the inside function. Again, the inside function is x, and the derivative of x is just equal to 1. Now let's simplify. This is gonna be equal to 1, and then x to 0, and x to 0 are just equal to 1, and therefore the answer is 1. And this is the same thing we found previously. So again, we have this simple function, h of x equal to x, but we can use all the derivative rules to take the derivative of this function. And each time we use these rules, we will have the same answer. So you gotta just use the simplest rule.